This is section 1.1, and we're solving linear equations, meaning that we are trying to isolate the x in the equation on one side and have everything else on the other side. And so the best way to do that, if there is one term that has an x in it, is to leave that term where it is. Think about your equation as a balance. And to get the 7 onto the other side, you want to subtract 7 from both sides. So we're using inverse operations to get this 7 to turn into a 0. And then all that'll be left on the left-hand side of the equation is the negative 2x, because the negative in front of the 2x means it's plus a negative. And 3 minus 7 on the other side is negative 4. Once you've moved any terms that don't have an x to the right side, then you can go and undo the multiplication that's going on between the 2 and the x and divide both sides by negative 2. And that'll isolate your x, and you will say the answer is x equals 2. So always a good idea to check your answer. So if you put the 2 back into the equation where the x is, the left-hand and right-hand side should equal. And they do. So I know I'm right. If there are 2 terms with x's, you need to get them onto the same side. So what I usually do is I look for the one that has a smaller coefficient, like negative 4 is smaller than 2, and I decide I'm going to move this one. By moving, that would mean I'd add 4x because it's a negative 4x and I need the inverse. I'm going to do that to both sides of my equation, and that'll leave me with 6x minus 3 equals 7. And then I can move the negative 3 over to the right where the 7 is, so that my x will be closer to being isolated. And that will look like adding 3 to both sides. Then I'll have 6x equals 10, so my x is almost isolated. I've got to undo this multiplication with division. And then I have x equals 10/6 or 5/3. Again, the best idea is to check your answer. So you'd want to plug the 5/3 back in and make sure that the left-hand side and the right-hand side end up with an equation. So I'll leave you to do that with your other, with each problem. You can check it just to make sure that we're right. Moving on to number 3. As they get more complicated and your x's have parentheses around them, or maybe there's a subtraction in front of the parentheses and brackets, what we've got to do is start on the inside of any parentheses or brackets and work our way out so that we can isolate all our terms and start moving them around. So the best thing to do is to look inside these hard brackets and distribute our negative. So it's negative x and negative 7. And then we can combine up. 2x minus x is x, so I have x minus 7. Now at this point it might seem like you want to distribute your 5 into the parentheses. However, because there's a 5 times here and a 5 times here, the better option would be just to divide those 5's away so that I just end up with x minus 7 equals x minus 3. So at this point you might be realizing something looks a little fishy here. How can x minus 7 equal x minus 3? And I would agree with you, that's never going to be true. If you take a number and take 7 away and take the same number and take 3 away, you're not going to end up in the same place. So maybe you realize it here. If not, if when you go to try to get your x's together and you subtract x from both sides and you end up with negative 7 equals negative 3, then there might be a clue that something funny is going on. And either place, you should realize that the answer is no solution. When you come down to a false statement, either place that you realize it's a false statement cannot be true at all, no matter what x is, that means that there's no solution to your equation. And that'll happen when your x's have the same coefficient. And the other terms in there are not the same. So that's a possible solution. When you have fractions, a lot of times people don't like to deal with fractions because they require common denominators. So I have a solution for that. We have 1, 2, 3, 4 terms here. And if I multiply each of those terms by the number 4, I won't have fractions anymore. The reason I chose 4 is what the common denominator would be if I were going to get one. So when I multiply 4 times 7x over 2, this 2 can divide into that 4 twice. And then what I'm really multiplying is 2 times 7x and getting 14x. When I multiply 4 times a fourth, I know I get 1 because that's the inverse property. When I multiply 4 times x, I get 4x. And when I multiply 1/4 times 4, again I get 1. That's the inverse property. So multiplying by 4 gives me an equivalent equation without fractions. And now I can take the smallest x term and move it so that my x's come together on the left to be 10x. And then I'm going to move my 1 to the right, because if the x's are on the left, the constant term should be on the right. And negative 1 minus 1 is negative 2. Divide both sides by 10 to get rid of the multiplication. And I get negative 2/10 or negative 1/5. Again, you can plug it in and check your answer, but the steps are pretty clear. You know, you didn't have to get rid of the fractions. If you're not uncomfortable with fractions, you could have done it with fractions. I just think it's faster to get rid of them. So the same would hold on number 5. I would like to not have a fraction that I need to distribute in here. So I would like to multiply this by the number 4, which will turn this into the number 1. But then I also had to multiply this by 4 and the other side by 4. Because everything that is subtracted by, or is separated by a subtraction or an equal sign in this problem has to get multiplied by 4. Now when I multiply 3/2 by 4, then it's going to get distributed into the x plus 4. So I only have to multiply the 3/2 by 4. I don't have to multiply the x plus 4 by 4, because then I'd be multiplying by 16 if I double multiplied. And that's because these are connected by multiplication. But when things are connected by subtraction, that's when you have to make sure you multiply each of those. So 4 times 3/2 is 12/2 or 6. Minus 4 times 1/4 is 1. And 4 times negative 3 is negative 12. Now that I don't have fractions anymore, I can distribute and make sure I distribute my negative. Then I can combine my like terms because they're on the same side. So I'm not moving anything yet. I'm combining up things on the same side that are like. So 5x minus x and 24 minus 8. And then I'm going to try to isolate my x here. So I'm going to move the 16 to the other side by subtracting. And then I'm going to divide both sides by 5 and get negative 28/5. Now you can leave it like that. You can write it as decimal if you like. You can write it as a fraction if you like. However you want to write your final answer is fine with me. And so 4 and 5 are illustrations of how to get rid of fractional coefficients if they're there. Number 6 is one where you want to use the idea that the product of the means equals the product of the extremes. And that's true anytime you have a fraction equal to a fraction. You can multiply the means together, which I'm not going to distribute it yet, but we know we're going to have to distribute, and multiply the extremes together and set them equal to each other, because that's a property we have, that anytime we multiply the diagonals, when we have a fraction equal to a fraction, we should get the same thing from each product. So now I'm going to distribute 12x minus 4 should equal 12x minus 4. Well, now we're in a situation like number 3, where our x's have the same coefficient. But when you look at it, in this case, this is a true statement, whereas the other one was a false one. X minus 7 didn't equal x minus 3. A true statement means no matter what I put in for x, left is going to equal right. So any number that I choose for x is going to make a solution. And so we're going to say all real numbers, because any real number on the number line will be a solution to this equation, as opposed to number 3, where no number that I could think of would be a solution. Moving on to number 7, I need to use some of those strategies that I had from section point 7 to either add my fractions together, which is one possibility, get a common denominator and add them together, because on the right-hand side, if I factor this, it's going to actually factor into these two factors. So I could put them together into a fraction, and then I'd have a fraction on the left equals a fraction on the right. So in doing that, remember the common denominator is the product of these two, because they don't have any common factors. And then the 1 is going to get multiplied by the x minus 1. And this one is going to get multiplied by this x plus 6. So my fraction on my left is going to end up being 2x plus 5 over x plus 6 times x minus 1. And on the right, I have 7 over x plus 6, x minus 1. Well, if the denominators are the same and the fractions are the same, then the only possibility is my numerators must be the same. So I don't really have to cross multiply in this case, because I have a matching denominator. I can just set the numerators equal. Take away the 5 from both sides, divide both sides by 2, and I have my solution of 1. Eight looks like we might want to do it the same way. However, if you notice, these two fractions already have the same denominator. So it'd be easier to put those two together than it would be to put the two that are here together. I already have the common denominator. So in this situation, the best thing to do would be to move the whole fraction by subtracting it from the left, so that I can then combine it with the one on the right that already has the same denominator. So my my left-hand side is just going to be the fraction that I had. And on the right-hand side, I'm going to subtract my numerators, 9 minus 7, and keep it over that same denominator. That's how I subtract fractions. And now I'll be at a problem like number 6, where I can multiply the means and the extremes and set them equal to each other. So I'm going to distribute as I go. 6 times 2x plus 6 times 2 should equal 2 times x minus 2 times 1. And now it's time to move things around. Since there's nothing I can combine on the left or the right, I'm going to look at my lowest coefficient on x and move my x's to the left. And then I'm going to have to move the 12 to the right. Since I chose x's on the left, my constant terms have to go to the right. And my last step is to divide by that coefficient so that I can isolate x. -7/5 is what it reduces to. So that's my solution. And again, you can use your calculator to check and make sure that's right. So the last problem looks like it's not linear, because I said linear means x is to the first power. But here I have a square, and we know that if I squared x plus 1, I'd end up with an x squared in it. So this looks like it's not linear, but what's actually going to happen when I square x plus 1, because I'm not going to make that silly mistake of thinking that I can just square the x and square the 1. That's not how it works. I have to FOIL it out. I'll get x squared plus 2x plus 1 when I FOIL it. Our outer and inner are both 1x, so that's 2x. Then I'm going to distribute my 3 through the parentheses. I'm going to FOIL the right-hand side. X squared minus 3x plus 1x is minus 2x. And 1 times -3 is -3. When I combine up my like terms on the left-hand side, I have 5x minus 2. And on the right-hand side, when I start moving things around, it's going to end up that the x squareds, when I go to move them from this side, they're also going to disappear on this side. So it looked like it was not a linear, but because I had an x squared on each side, it is linear. And now I can add 2x, because like I said, I like to use the lowest coefficient on x to decide what I'm going to move. 7x minus 2 equals -3. Add 2 to both sides. 7x equals -1. And then finish it out by dividing by 7. X equals -1/7 is my solution. And again, plugging it in, you can check and see that it is a solution. It makes the left-hand side up here equal the right-hand side. You want to plug it into the original, because otherwise we might have an issue where we made a mistake and this is a solution to the mistake we made. So you always want to go way back up to the beginning and plug the -1/7 here, 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 and here in your calculator and make sure left equals right. So this is how we go about solving linear equations. It's all about trying to get an x all by itself on one side. They start off fairly simple and then they get a little more complicated, so you want to work through the WebAssign, and we'll go over any questions that you have on that on Monday. Thanks.